Thank you very much, Nick. And just share my screen. So hopefully you should all see that. I put it in presenter mode. I think we've got 10 minutes, so I'm going to rattle through sort of the background between Artemis and what we're trying to achieve as a business, and really get into sort of the meat of the discussion on digital twin. And Nick, you're quite right. Digital twin means many things to many people. And what I want to just discuss is, what we're interested in as the business. So the first thing is Artemis Technologies. In terms of company, we set up in Northern Ireland a couple of years ago, mainly to really sort of help drive this mission of leading decarbonisation in the maritime industry. And we're really looking at innovative, sustainable technologies and products. And we're building on a sort of rich heritage of America's Cup sort of participation and high performance competition in yachting. And we've transitioned to take that technology, particularly around hydrofoils, effectively underwater wings, and combining it with aerospace in terms of flight control, autonomous flight control systems, and also Formula One energy recovery systems to create these zero emissions maritime vessels. But we can't do it by ourselves, and one of the parts of the reason of being in Northern Ireland is to work collaboratively with a large consortium. We formed the Belfast Maritime Consortium of 13 partners, which we lead, and the consortium members are obviously listed here. And this slide gives you a feel for the type of vessel that we're building. Everything zero emissions, high-speed foiling vessels with a range of different attributes, from zero wake to very quiet, very good ride comfort, this is really transformative in the market. And we aim to actually have a demonstrator in the water towards the end of this year, beginning of next year, a much smaller vessel, which you can sort of see at the bottom of the page. And this larger vessel at the top is a sort of 250 passenger water ferry, which we'll be demonstrating between Bangor and Belfast. And in terms of project, we have £33 million of UKRI Strengthened Places funding to help support this £53 million programme. So getting into sort of the actual digital twin aspect, so the traditional development programme, which I come from a aerospace automotive, albeit Formula One, but I worked quite a lot in automotive OEMs over the years. And going back, the traditional design process for a complex system is a left to right development V, where you start with an idea, either market input or design with a concept. You work your way down the V, creating from concept design to system design to component design, getting an optimal concept, and then you work your way back up the V, making bits and testing them. You start with the component, then the system, then the full system, and then multiple prototypes. And going back maybe 20 years or so in the automotive industry, you would literally have hundreds of prototypes for a new car vehicle. That's very costly, takes a lot of time, and also you lead to a lot of rework, costly rework. So from a sustainable design process, it's not very good. There's a lot of wastage in the process. And time costs money. So the time taken to go from market input to market product, to product in the market is obviously substantial. And the whole process about this digital twin is to take this V and try and collapse it as much as possible and go from idea to product as quickly as possible. So what I just wanted to show you today is what we do at Artemis. And like a lot of high performance or companies that have had their sort of roots in high performance sports, we have invested significant amounts of money, just under about $250 million in our tools and development process and our simulation to really be able to fast track this process. So over over a decade, we've created a bespoke digital twin process. And I'd like to just concentrate on the bottom left, where we have the simulator, the human and real-time simulator, mechanical hardware in the loop simulator at the hub of our process. And on the spokes, then we have different sort of subsets, whether we have testing and validation on water validation, computer-aided design, high-fidelity computational tools. We are bringing in, as you see, with our collaborators, academic research, and then we have sort of looking to put in place high fidelity testing equipment that runs real time in the loop with our simulator. Our simulator is just shown here in the top. I'll go through that in a bit of more detail in the next slide. But we've developed that over the last few years. And the one thing I would say about simulators, and I've been involved with simulators right since sort of the late 90s when I was at McLaren and we were developing the first F1 simulator. Actually, the hardware isn't the important bit. The important bit, secret sauce, for want of a better word, is in the queuing systems, the integration, the software that goes in to make it an immersive experience. You know, it has to go beyond somebody gets in and thinks that they're in a sort of, they're not in a real environment. And then being able to hook real time in actual hardware. So we want to be able to run real time the electric drivetrain, for instance, of our vessels, real time with the simulator. So before we even get into the water, we've not only optimized from a performance perspective, but we've also de-risked the actual hardware. So in terms of potential maintenance issues or things which would trip you up traditionally in this multiple prototype stage, we don't need to do these multiple prototypes. By the time we stick our boat in the water, we know we're 99.9% there. So over the years, we've developed this suite of tools with different levels of fidelity to be able to run the tools real time in the loop with the simulator, with the human in the loop, and also with hardware in the loop. And what I'd just like to just finish is there's a bit of talking in this slide, but I've actually just muted it. That's not the important bit. This is the simulator. Actually, if you see, you probably see in the back, there's a little sort of big black box behind me. This is where our simulator's sited in our Northern Ireland facility. But I did a little bit of wanted to show you in a bit of stop-go photography the simulator being installed here from our English base in our Northern Ireland base, and the synergies that Nick and Beth talk about are absolutely there. So everything from cybersecurity to the electronics to the screen side, and the integration with a lot of the actual activity that's ongoing here in Northern Ireland, particularly around City Deal funding, is very much there. So from a perspective of us, we want to use this tool to de-risk not just the performance, but also the hardware, so that we don't have to do these multiple stages of prototype. What you see on the sim is actually a CLGP cockpit, but we can remove that cockpit off our simulator and actually put in the cockpit for any of our vessels and be able to replay the screen to show the real environment. We can replay any wave and water state, sea state that we want, and effectively tune the performance of the vessel and tune the pilot, and from a skills perspective as well. So again, it's not just performance of the vessel, but it's performance of the crew on board too. So this is a unique capability. And sometimes world class is an overused term, but this truly is a world class facility here in Northern Ireland. I'm very, very happy to be collaborating with the universities and companies and the local councils, etc., to develop what will be the world's most advanced zero emissions vessels. And the first one of those will be in the water by the end of this year, beginning of next. But it's a result of this digital twin capability. Thank you, Nick.